So next up, we have Kenny talking about the right way to run one of these conferences. Kenny is a member of the video team for KDE and has been involved in the running of Academy for a long time now. He has spoken before in Aberdeen about building video services, and he told me earlier this talk is much better when you get to play with the Raspberry Pis and the cameras in person, but he'll do the best he can. So here you go, Kenny.
Thanks very much, Tom. First off, thank you to everyone who's put this together. I know it was kind of a bit difficult to pull what would have been a really good event outside into something as awesome as it has been online. So I know it's been quite a lot of hard work and a lot of planning. So again, thanks for doing that, and thanks for having me. So hi, I'm Kenny. Some of you may have met me before doing some talks in Aberdeen. I normally talk about video streaming, video recording stuff, because I seem to kind of typecast myself a little bit there. But in my day job, I work on making archives a bit more discoverable with our metadata and things like that from BBC. And in the evenings, I do things like this, mainly for KDE, or under the KDE banner more recently for events like Linux App Summit and Academy. So a couple of notes about this particular talk. So I've covered video hardware in previous talks, so I'm not going to cover it here again. I don't really have hardware to hand around to people, which means that my major prop and time sync is lost to me, so that might kill quality a little bit. And I may also mention AWS a lot. What I'm talking about in regard to the public cloud here is possible across Google, or across Google Cloud, Azure, AWS. You can also do it with Scaleway and DigitalOcean. I'm pretty sure you can also do it with OVH now as well, but I will mainly mention AWS because that's where I'm most comfortable. And we built it last year for Academy on AWS, mainly just because that's where I live most of the time. And like I said, this talk is mainly untested remotely. Again, I'm not really props to hand around. So I've got some recordings of a demo that I created yesterday, really because running an RDP session might actually kill my ability to do a talk over the internet. But that might not flow very well, so I'll apologise in advance in case that's not quite fun to watch. So if you're doing this professionally, well, first off, I'm just going to talk about live streaming in general. So say, for example, you're live streaming a large professional conference, 2,000 attendees, 10,000 people watching it, maybe 100,000 people watching it. You would be using high-end cameras, and you'd normally rent them. They'd be about £10,000 a camera, plus they'd be using SDI rather than HDMI. The SDI from those cameras will go into a central video router, which will then get mixed using dedicated hardware. And normally you would have some form of CG or compositor system to then output that to some system that can distribute it over either Akamai or something else. If you're not doing this very often, it's really painful to get up and running. It's really expensive to do, and it's really slow. If you're doing it as part of a hobby, the amount of time spent post-processing pretty much makes it a very unfun hobby to have. I might moan about that a little bit during the talk. And normally it involves lots of months of planning and testing just to make sure things are going to work. So something I spoke about before is how we try to do this a bit more lightweight for the free software events that we run. I know Tom said I'm going to talk to you about how to do this properly, but a lot of this is very experimental and very much how not to do it properly quite yet. We're still developing this a little bit. Also, but things always go wrong, but that's just normal. So doing this in free software, it's very similar to what you would see at Twitch game streamers do nowadays. They would be using probably webcams like C920s. They would be using a reasonable gaming headset. For free software, it's a little bit different because we try to use free software and hardware to actually do it. Needing to rely on so most HDMI capture devices only work on Windows, unfortunately. That's getting better, but the stuff that you would buy off the shelf normally works in Windows only without a significant amount of prodding. So at least for KDE things, we try to do it using entirely free software and hardware where possible. So we use Raspberry Pi cameras a lot. I'll talk about that later on as well. We also try and just use a lightweight pass-through HDMI capture. For the most part, we don't buy large HDMI capture devices. We just use Link and HDMI extenders. I'll talk about those later as well. The audio capture hardware, annoyingly I can't move the mic, but we just use an Alesis IO2 with some HDMI port, with some XLR ports on it. And for your video mixer, we just use OBS. There are multiple video mixers that I'll go into later on, but that's really what we do. And one of the biggest challenges that we have is that everything we buy is really hard to justify the cost, because the events that we run are for 1 weekend a year, 2 weekends a year. We might spread out and help another event, and that'll be another 3 or 4 weekends a year. But out of a year of 365 days, you'll be using this hardware for 5 days. So it's really hard to say, hey, I need a really, really fast GPU so I can do that 2-day event, for it to then sit in my garage for as long as it needs to sit. We obviously do lots of testing and lots of research and development over the year, but you can still imagine it's quite hard to justify buying that hardware permanently. So when we started looking at this, we realized that there was a couple of, this is where I'm going to come across as a software engineer and treat every problem like a nail with the one hammer that I have. But you'll notice that we have some common patterns here. You've got a data sync for your final recordings, so basic data storage. You've got your video capture, a couple of cameras, audio capture, a couple of sound devices with XLR inputs. Network routing, again, more and more video production systems are IP-based now, so network routing more than analog routing is important. Monitoring of the various systems, is it actually alive? Is it doing what it should? Is it in trouble? Do I need to replace this hardware? And equipment control, as in switch to camera 1, switch to camera 2, that sort of thing. All these common patterns they look familiar. And when we were looking at this, and then we looked at the fact that, like I said, it's hard to justify £2,000 on a laptop for something that you're going to use for 2 days. We started wondering if there was a way that we could scale this out a little bit more. And then we realised that based on these common patterns, you probably know where it's going, but we know this. We're engineers, we're software engineers, hardware engineers. It's a Unix system. And we've been sold this story from AWS and from all these other vendors that if you can't justify the cost of hardware, then just rent it from them. So we thought, can we actually move this to the cloud? Can we move the majority of our problems to the cloud and never need to buy high-power laptops again, and try to make this as reusable as possible in a way that you can just simply turn off when you're not using it? So when we did this, we started a bit of analysis on what we were able to move. So we realized we can move the data storage. You can use Amazon S3 or similar just for object storage. There has been a pattern of moving the media storage for large broadcasters to object storage rather than just file system management. The network management, again, core substrate of all public cloud systems is their network. They give you services that hide all that away, but you can still access the core network and change all the routing config. The master streaming coding, again, this is where moving it to the cloud kind of gives us a lot more power, because if it's not fast enough, you just get a bigger box. And the video mixing, again, I'm going to be talking about OBS to do the video mixing side of things today. But as long as you can get your video stream somehow into the public cloud, you can then use any form of video mixer that you want. What we can't move, unfortunately, is the cameras. Still need to, although Tom Hibby, you've actually proven me wrong here, because the cameras now live in everyone's house for this remote conference. So we need to try and do a bit more of that. The microphone, same thing. Screen capture, again. All of these things are normally in the majority of events on site, and you cannot move them. Fair enough, screen capture, you can maybe get a copy of their slides and do something else, but that's just complicated. And unfortunately, you can't move the presenters as well. It'd be nice if there was an easier way to get all the presenters into one place at the one time. So one thing that so for last year's Academy, we focused around the Raspberry Pi. I'll mention a couple of slides in the future that we've since developed this a bit more, but we focused mainly on the Raspberry Pi for Academy. We used 2 Raspberry Pis for cameras. Those same Raspberry Pis acted as audio inputs, and we also used the Raspberry Pi to capture the presenter's screen. And I'll talk about how we did that in a couple of seconds. So the Raspberry Pis mainly have this video sensor that you can see here. The Z cam had the V1 sensor, the W cam had the V2 sensor, because of the type of mounts that we could use at the time. It's possible, like is much easier now because they've just released the new camera sensors and lenses officially for the Raspberry Pi. So this is going to get even better. But at the time, the Zoom cam was using the V1 sensor with a differently configured lens as we had for the wide camera, allowing us to just make it a bit more exciting, so that if you've got question and answers, you can go to the wide view of everyone. If the presenter's walking about, you get the Z cam. The audio input, we had one per camera, and the reason that we had really just so that we had a backup if something went wrong. And again, that would just XLR into a USB 7 device, pushed out using, I'll go into it in a second, but we were basically sending a video feed with a single slate, but with the audio over the top. The presenter capture, we had HDMI extenders, and that if you plug HDMI in one end, with Ethernet in the other, you would normally have another one of these devices at, say, 100 meters down the line. It would take the data over the line, turn it back at HDMI, and plug it into the TV. But it turns out this is just multicast, so as long as you get a fast enough Ethernet adapter plugged into the Raspberry Pi, you could capture that and send it to wherever it had to go. So you've got a Raspberry Pi that sends 2 video streams, one for audio, one for video. You get 2 of those, and you get another Raspberry Pi that takes your Ethernet in on one end. That is your multicast. That's your multicast consumer for the slides, and on the other side, that just sends you that just muxes it down a little bit and sends it out to your video router. A point here that I'm going to make is that the video we were sending from the Pis is about 1 to 2 megaseconds. The audio is significantly lower because we care about the video on that one, but we are deliberately losing quality here because you do have a bandwidth constraint, and the Pis themselves do have a CPU constraint as well. But when you think about it, you're sending most consumers of the video are probably going to be watching it about 4 megaseconds anyway. So normally you don't really notice it when you're consuming the feed. We also keep a copy of the raw for post-processing later anyway, just in case that is utterly terrible. And we learned a little bit last year that it can be utterly terrible depending on your circumstances. Another point that I'm going to go into a lot in this talk is the fact these Raspberry Pis connected to a single OpenVPN server on AWS by default, meaning that we could just send that video straight to a private network that we could access on the OBS instance. Another thing that, like I said, another thing that we've kind of developed since Academy was the concept of a single video router in the middle. Traditionally, in a broadcast environment, you'd have an SDI video router that would take all your cameras in one end, and it would allow you to map, say, for example, 1 camera to 3 outputs. A good example of this would be a news presenter sending the camera out. That could then be sent to a compositor so they can swap out some text and add some additional things, but you also want to send a live feed of the camera itself to the master control room, because if the compositor crashes, you can still send that camera out to broadcast and you don't get dead air. One thing we realized is that we could do the exact same thing just using a basic Nginx and RTMP server. We can get every Pi, every webcam, every audio feed that you can think of, send it just in the exact same format to an RTMP server with a different path for every one of these, and just access that as you need to from OBS. So by doing it that way, you've now muxed everything into the exact same reusable format in a reliable way, and you don't need to worry too much about, okay, if there's connectivity issues with that Pi, then your RTMP server is going to deal with any additional renegotiation, and the consumer, OBS, just doesn't need to care. Next with OBS. So this was a bit harder to set up than we initially thought. So the reason we're moving this to the cloud is because we need a fast machine to run OBS. Every year, your resolution requirements increase. 10 years ago, we were doing SD and it was fine. We just had FireWire cameras everywhere, and FireWire's it's lots and lots of data, but it's quite lightweight CPU-wise. Now we're looking at doing 1080p. I hope that we're not asked to do 4K at some point. But even if we are, we can still manage the encoding of it just by increasing the instance size. The demo that I'm going to show you was on a C5D X large, which isn't no, C5N large isn't quite fast enough to do what we're doing for Academy, but it's fine for the demo. I think C5N 4x large is probably what we would use nowadays. That's effectively 8 CPUs and about 32 gig of RAM for a production environment. But again, you're only doing that for a weekend, so the cost is pretty negligible. The hard part that we found was actually trying to get remote desktop to work in Linux. So we initially made the assumption that remote desktop was a solved problem. So initially we thought, hey, Windows has been doing our RDP for a long time. We can do remote cloud gaming. It works totally fine. All I need to do is install VNC on this server, connect to it, and jobs are good. And the most complicated part here was actually getting the correct mix of remote desktop server and client. And eventually we ended up solidifying on XRDP, which is just a RDP shim on top of VNC. It does some user management for you, and Ramina, which is a fairly modern remote desktop client for Linux. The standard RDP, I think even KRDC wasn't very good for this because it just didn't scale that well. It couldn't really handle logouts either. And it took a bunch of hacking around to get the Xorg config working as well. I am going to post a lot of this onto GitHub after this talk, so that you can just copy and paste it if you wanted to do it. What we ended up doing with this particular instance, because it was probably the most complicated part of the project, was just making a reusable AMI from it. And we end up using that a bit further down the line as well. And then the next part was OpenVPN configuration. Nothing too special with OpenVPN. It's just apt install it, basic configuration, except we make sure that we have a certificate per device. And we make it easy enough to deploy a new certificate onto a device if we need to. One thing I didn't mention with the Raspberry Pis is that Pis are the reliable. Well, the Pi 3 is significantly more reliable than the Pi 1, but at the same time, you're working under pressure. Sometimes it's, I mean, we ran it in Italy last year, but in Spain the year before, and the heat there is significantly different. Well, probably a bit closer to it today in Scotland, but the heat on site normally breaks a couple of Pis. So what we want to do is make it really easy to just deploy a new one. These Pis themselves are all deployed with the exact same image, but just get a different cert every time, and you enable or disable the things that you don't care about. But yeah, the next important thing about the OpenVPN config is that where OpenVPN normally provides NAT to the clients, treat it a bit more like a traditional router. You want to be able to access the OpenVPN clients on the 172.16.0.0/16 range from your Amazon VPC, and that's quite important. At the same time, you want to be able to access your Amazon VPC from the Pis. AWS allow you to do this quite easily, so you'll see in my screenshot here that the route table for my Academy subnet here has the 172.27 going to that particular ENI. That ENI is ETH0 on the OpenVPN instance, and the OpenVPN instance has been configured just to masquerade traffic across into the 172 range. At the same time, if you happen to be on there, you can access the 1068 network. A note here to talk about is that you'll notice I only have one subnet, which means, for those of you who use AWS, you'll know that that's one availability zone, which means that if that one availability zone disappears, then we're a bit scuppered. So that's a technical decision we made at the time, mainly because if we work across multiple availability zones, then we're going to end up in a situation that you might be paying for cross-AZ bandwidth, whereas in this case, we didn't want to pay for the video bandwidth going across various Amazon sites. There was also some slight latency constraints there, but at the same time, I think those are relatively negligible and measurable. And another thing that we ended up building, we can generally trust everyone that is involved in this on site, but at the same time, we wanted to limit the risk entirely. So we built this mini dashboard that allows people to turn things on, turn them off, just check that things are healthy. Scrolling down on this dashboard, you can also see a once per second snapshot of what's actually being captured on all of our cameras. And then that means we can see at a very quick glance, has a camera operator got that camera pointed at the presenter? Because sometimes it's quite helpful to know, because sometimes the camera operator might disappear for a couple of seconds. So this is where, like I say, I'm going to do a couple of videos for demos because I don't want to end up breaking the network connection. So in this demo, you'll see that I'm connecting to a Raspberry Pi that I have in the house. I set it up yesterday, it's still running. And you'll see all I'm doing is connecting to an RTSP server on the Raspberry Pi. Nothing too crazy, but what it does is it will show you a video of myself and I'll be waving, and apologies for the stairs that I really need to tidy. And the second part of the demo is where I'm connecting to that exact same Raspberry Pi. Zoom has taken focus. 2 seconds. Cool. So I'm connecting over RDP to this Kubuntu instance that was set up and just starting OBS. I've got a couple of videos here that I've been using to test. The video on the left-hand side is a standard CCC test video. The one on the right has a stupid resolution that I've been using just to prove that the server can handle the load that we're throwing at it. You'll notice here, if I should have paused that there, but you'll notice the IP address that I'm hitting is actually the 172 address on OpenVPN. So that's connecting directly back to my house, to the Raspberry Pi, and feeding the video there. In this case, I'm not using the RTMP bus in the middle, because this is how we did it last year. The RTMP bus is a fairly new thing. Cool. And I am just going to close that now. Yeah. So one thing you would probably notice with that video is Zoom definitely wouldn't have helped, is that it was quite choppy. RDP sucks. RDP is not great for this sort of thing, and I'm hoping it's going to get better. There is a VNC source plugin for GStreamer, and we might end up doing something like that and have a custom feed for that. But for the time being, RDP is what we're doing. We just need to do something quick and dirty so we could press some buttons. So what we ended up doing was building an OBS to MIDI bridge. And that OBS to MIDI bridge was just an Akai LPD8 that you can see in the image here. And the buttons on the left-hand side were configured to allow you to move from scene 1, 2, 3, 4. Every scene was statically configured to be full cam 1, full cam 2, pick and pick. You see the sort of thing that Zoom can create here. It just does it over a WebSocket. So if it happens to be that you're on the same network, albeit on OpenVPN, you can just connect straight to the OBS instance. And it also means that you can just say very quickly, without needing to worry about the feedback loop of I press that button, I wait 3 seconds, I see something changed. In order to get a real-time view of what's actually happening on the cameras, we just use little 10-inch, you can buy reasonably priced 10-inch 1080p screens now with that, and you can get an HDMI switch for those. So all the Pi's plugged into this HDMI switch, and you can just flick between them. What is coming through the camera frame buffer is output onto the main, just onto the main view on the Pi, so that works fairly well. So the next thing that we wanted to think about was monitoring. So we wanted to make it really easy to determine is something broken. So we ended up just setting up the TIG stack. All of the Raspberry Pis, as you can see here, Raspberry Pi.cam1, that's just from the demo yesterday, have Telegraph installed. They're all sending just live CPU memory network stats straight to InfluxDB. So if something's going wrong, we can alert on it. But something else that we kind of realized is that it's just a time series database that can take anything. So we started pushing effectively business actions to it. So you push that button on OBS, or you push that button on LPDA, and that item gets recorded to InfluxDB. So say for example, the Raspberry Pi starts recording a new raw file, that pushes up there as well. This becomes super helpful later, not only for root cause analysis when stuff inevitably breaks, but it also helps us a little bit when it comes to post-processing. So for post-processing, you notice that I mentioned that we reuse the AMI image for the OBS instance that we have on AWS. So if we're able to rsync all of the raw footage from the Pis onto Amazon S3, and we're able to, say, for example, access these from a cloud-hosted GUI running Kdenlive, using an Amazon role that allows you to access that particular S3 bucket without the user even noticing that there's an authentication layer in the middle. We are then able to give a bunch of people access to cloud editing machines, especially if you're doing it outside of non-broadcast times when you're not too worried about bandwidth. You can make that frame rate a little bit better, and you can access all of that. So that, coupled with the fact that we now have all of the business events as well to tell us, during this time, the director during the event pressed this button to move to camera 1, to move to camera 2, we can load that CSV into Kdenlive as well. And we can use that to effectively remaster the live feed that we were pushing out to YouTube or whichever RTMP endpoint we were using. This is my current focus of research, because we haven't quite got this working yet. Kdenlive just consumes XML files as its main file format. I'm hoping to be able to generate a live Kdenlive file from the files that we've recorded, so that we never need to worry about actually reading a CSV and figuring out what the timestamps are. Ideally, it should just be a case of someone booting up an instance. There will be a file per talk pre-made, and we can just click a button and start it up. I have deliberately skipped chat about the talk metadata that we use. I know that we've used pre-talks for campGNDd, but at Academy we've used Frab, where I get looking at whether or not that's going to be what we use in the future. So, like I said, there's a couple of limitations. At the moment, we are limited to the bandwidth available. At the university that we hosted at last year, we had effectively a gig link per room, which was quite nice. At least I think it was a gig link. We never really burst it. We are at the moment limited to OBS only. Another focus of research at the moment is to move this to Casper CG. For those of you who saw my last talk about VoctoMix, Casper CG is a really good middle ground between OBS and VoctoMix, and it allows you to build your own control plane, your own control software around that, and overlay HTML5 as kind of interstitials for that, with lower thirds and things like that. And you're limited to raw processing capabilities. I don't think we can ever be in a position that we'll be able to send a raw contribution feed from a camera, unless, of course, well, I'd imagine 5G might do it, but at the same time, if you're in a room with 300 people, I expect everyone's going to be using up all of the 5G network around you. And like I say, what's next? We're going to try and improve the automation around this. At the moment, none of this is CloudFormation, so that needs to be fixed. I want a bit more creative control, probably using Casper CG. I want to support more hardware. We focused on the Raspberry Pi last year in particular, just because it's what we had, and the Raspberry Pi cameras were very core to what we're trying to achieve. And the main thing I want to do with all of this is turn it into a reusable toolkit that anyone can deploy. At the moment, there's a blog post going out in the next few days about how to do all of this, but at the moment, it's quite cumbersome to go up and running. It takes about a half day to boot everything up and test it and everything else. I'd like to be able to just deploy a single CloudFormation template, run some Ansible on some servers, and jobs are good, and you've got this up and running. And then, if possible, just a couple of Raspberry Pi SD card images that you can just put anywhere that you want to go. So, like I say, I'm not sure how well that went remotely, but again, thanks for having me. And any questions?